Mathematics 1 Sketching Graphs. In this video I'm going to give you some hints on how to answer the questions 5 to 8 on tutorial 4. If we look at the data, you can see that the voltage goes up in regular amounts, but the current doesn't. So that implies that the voltage is the independent variable and the current is the dependent variable. So what we're going to do is we're going to plot volts on the x-axis and current on the y-axis and measure the gradient. The gradient is the change in y divided by the change in x, which means it's the current divided by the voltage. Ohm's law says that voltage is equal to current times resistance, and if we rearrange that, we get 1 over the resistance is equal to the current over the voltage. So here we've got the current over the voltage, here we've got the current over the voltage, which means that the gradient dy by dx is equal to the inverse of the resistance. Question 6. In this case, the mass goes up in regular steps, so it's the independent variable, and the dependent variable is the extension. So we're going to plot mass on the x-axis and extension on the y-axis. The gradient is dy by dx, which is going to give us the extension over the mass. Now Hooke's law says that the force is equal to the spring rate times the extension, and if we rearrange that, we're going to get 1 over the spring rate is equal to the extension divided by the force. Here we've got extension divided by the mass, and if we remember that force is equal to mass times the acceleration due to gravity, we'll get that the spring rate is the acceleration due to gravity divided by the gradient. Question 7. In question 7 we know that t is equal to 2 pi root L over g. So if we plot L against t, we won't get a straight line. So what we need to do is to create another row for t squared and plot L against t squared. The gradient will then be 4 pi squared over g, so we can find g from the gradient. Question 8. Time is going to be the independent variable and nt is going to be the dependent variable, and if we plot time against nt we won't get a straight line. So what we have to do is to take natural logs of this equation. The natural log of the left hand side is just log nt. The log of the right hand side is going to be log of n0, which is a constant, plus the log of e to the minus t over tau. Now log and e are inverse operations, so we just end up with the exponent, which is minus t over tau. And if we plot log of nt against t, we will get a straight line. If we compare this equation with the equation of a straight line, you can see that we've got a constant and a linear section, which means that we can use the gradient to find the half-life.